So we're now going to take a look at the different ways that two triangles can be congruent. Sometimes it's really easy. They tell you, hey, these two triangles are congruent, and so then you know, because they're congruent, that all three pairs of angles are congruent and all three pairs of sides are congruent. But sometimes they just give you enough information, in fact, 3 pieces of information, and you have to decide if it's in the right configuration to decide, hey, yes, these two triangles are congruent. So the first two we're going to look at are something called SSS and SAS congruence. So SSS stands for side, side, side congruence. And what this means is that you're given that three pairs of sides in two triangles are congruent. Meaning, you've got a triangle over here, let's say, and you've got another triangle over here. And let's say, oh, okay, this side, that's congruent to this side. You know that this side, it's congruent to this side over here. And last but not least, you're told that this side is congruent to this side. In other words, you're given that all three pairs of these sides are congruent. Notice that you're not given any information, no info about the angles, right? You're not given any info at all about the angles. Can you conclude then that these two triangles are congruent? Yes, because you have all three pairs of sides are congruent. The argument is that if you have this length and this length and this length set, there's only one way to put it together, and you're always going to get the same triangle. It might be turned around or reflected or anything like that, but it doesn't change that it's the same triangle. The other one that we're going to look at least right now, is something called side angle side congruence, which means that you're given information that two pairs of sides are congruent and one pair of angles that are between the sides are congruent. Now it's kind of important, this between thing. You'll notice that, so we got S and S, which means two pairs of sides, one pair and two pair from one triangle to the other. And then A is in between these, meaning the angle has to be between. What does between mean? Well, let's say I have another triangle and yet another triangle. We'll make this easy on ourselves. Let's say we know this side's congruent to this side and this side's congruent to this side. That would be two pairs of sides. One pair, two pair. Yes? Where is the angle between? So the angle between these two sides, so these are the two sides that I'm given that are congruent. This angle between them would be the angle formed by those two sides, which means if I had this, so I have a side, the angle would be between them. So I'd read that off, side angle side, right? And then here, side angle side. And I could say then that these are congruent because two pairs of sides, and then the angle between them is also congruent. It still ends up being 3 pieces of information. Please note, I don't know anything about the other angles, and I don't know anything about the other sides, okay? And I can safely say, yes, there's only one way to put those together. That is side angle side congruence. Two pairs of sides, and then the angle between are known. So we're going to take a look at some examples, and that'll help make this a little bit more concrete, I think. All right, so determine if the two triangles are congruent. If they are, state you know how. Now remember, no matter how they look, you cannot conclude anything about lengths or angles unless it's a known property. Thinking back to the vocabulary. So, looking at this, you hopefully see that there are some vertical angles here. And as a matter of fact, this angle and this angle, vertical angles are congruent, so you can safely conclude just from the drawing and how it's laid out, this upper triangle, lower triangle, that these two angles are congruent because they are vertical angles, okay? However, all that gives you is, because you have these two tick marks too, but you get this side, and you have this angle and this angle. All you have in this triangle is SA and SA, and that's not enough information. So not enough info, so you cannot safely conclude that these are congruent. Now, looking over here, hopefully you see a left triangle. So if I've split these into 2 pieces, right? There's a left triangle and there's a right triangle. These are nice technical terms, right? So if I split these apart, there is something that is happening here. They do share this side. So can we safely say that this side's congruent to itself? Yes, and that's because of the reflexive property. Okay? We can conclude that because they have a shared side, in reality, if I were to split them apart, because they have the shared side, they'd have these 3 lengths, which means that these triangles are congruent by side, side, side. All 3 pairs of sides are congruent. Boom. So you have to look at the configuration. Sometimes you don't. So if you look here, I've got this side corresponding to this side. So I got a side, one pair of sides. I got another pair of sides here and here. Here I've got an angle, and here I've got an angle. Is that enough? This angle is between the 2 sides. So we'd say the configuration here is side, angle, side. This is the angle between. No, that would be this angle down here. So we call this side, side angle. Not enough info. Remember, we want to be able to definitively conclude that these are congruent. And right now, all we've got is a side, angle, side configuration. And we have to have the same configuration over here to safely say it. Or, and this is pretty straightforward, one side, another side, another side, another side, another side. These are congruent by side, side, side. So they are congruent, we can conclude, because I have 3 pairs of congruent sides. Okay. Oops. A couple more examples down here. Same thing here. 1, 1, 2, 2, 3, 3. Congruent by side, side, side. No one ever said this had to be particularly difficult, except when you get to something like this. So we got a side, we have an angle, we have an angle, but we also have the drawing that we can use. Can we safely say that this side, now 2 tick marks is already taken, so I'm going to use 1 tick mark, that this side is a shared side and therefore it's congruent to itself? Yes. That's because of the reflexive property, right? That enables us to say that's congruent, which gives us another side in each of these. So these are congruent by side, angle, side, because you'll notice that the angle is indeed between or formed by each of those. If you were to split them off into 2 separate pieces, you'd have a 2 here, you'd have 1 tick, 1 arc, this, and then there's that shared side, so you have 1 tick mark, 2 tick marks, and 1 arc. So are you allowed to conclude stuff from the drawing? And the answer is yes. For instance, we can safely say that this angle here is congruent to this angle here because of the, not that property, because they are vertical angles and therefore congruent. However, what does this give us? Angle, angle, so 1 pair of angles, 2 pair of angles, 3 pair of angles. A. Nope. Not enough info. Why? Because it's not side, side, side. It's not side, angle, side. We're going to add some more tricks to our bag, but even with those, we still couldn't say that these are congruent. So hopefully by now you're starting to see that this side is congruent to itself because of the reflexive property. In other words, if I was to split it into 2 triangles, well, that would automatically be the same. So these are congruent by side, side, side. Okay. So now, working in another way, what if we had this drawing with these markings? What else would you need to get side, angle, side? One thing you wouldn't need is, because these are vertical angles, you know that this is congruent to this. So right now I have a side and an angle, and a side and an angle. For side, angle, side, I need the other side. And what side must it be? This side and this side. So we would need that NM, this side right here, is congruent to this side, JM. And if I had that information, they'd be congruent by side, angle, side. Same idea here. Got a side and angle. I want the other side that makes it up, so it must be that side. Side and angle, that. So what must be added? What additional information must be known? Well, we need to know that GH is congruent to ST. So what you're doing is you're writing down what information would need to be added so you could add it to the drawing. Okay. Side, angle, side. Here we go again. Now, as a little bit of practice, I'm going to name these angles slightly differently, but I don't think you'd agree, because we have this side and this side. We're talking about this angle and this angle have to be congruent. Now sometimes we're going to have to be able to name these using 3 points. K and U would be the vertices, which means we could say LKJ, right? LKJ, that's the angle, is congruent to what over here? VUT. Now technically, does it matter if you said TUV or VUT? No. Angle U and angle K, that is, those K and U are the vertices, right? Those are the vertices. But just remember, you can name angles, and sometimes you might have to, if it's ambiguous, using 3 letters. If you said angle K is congruent to angle U, in this case it would be okay to do that because there's no argument about what angle K and what angle U are. So here, side, side, side. We already know this, and that's because of the reflexive property. In other words, we don't need to name that side is congruent. We can conclude it safely from that, from the fact that it's a shared side. However, we would need the third pair of sides, side, side, and side, right? So we'd have to add that US is congruent to SR to make it a complete package argument, right? So another side angle side, and this one's tricky. This we get because of the reflexive property, right? So we don't need to name that. But looking at this, let's say this upper triangle here, right? I got a side, got the angle. I'd need to know that this side is congruent to side angle this side to get the side angle side configuration. So I'd have this upper triangle and I have this lower triangle, right? Because they're shared, this is congruent to this. This angle is congruent, and peeling these off is congruent to this over here. And then I'd need to add this side and this side. So I need to know that KJ is congruent to JF. Okay? Oh, that's an I. IF. Sorry. Don't misread it. IF. Okay? Side, side, side. Pretty straightforward. We need to add this side. 1 tick mark's not taken. So we'd have to add KM congruent to UW. It is easier if they don't overlap, because then they have to give you more information, right? If they do overlap, then we know because of the reflexive property, right? That's congruent. So now we just need to look at what we need to add. Side, side, side. So we need to add this side and this side. That is TF congruent to UV. Remember, you can switch these around, FT, VU, whatever. Doesn't make any difference. So here's another reflexive property. Basically saying this is congruent to itself. We want side angle side. So in this triangle over here to the left, side angle side. Side angle side, which means we have to know that WA is congruent to VU to safely conclude by side angle side that these are congruent. Now hopefully that has helped you determine when 2 triangles are congruent and then what information you need with respect to side, 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 and side angle side.